Okay, it's recording now. So I'm not sure how good the audio will be because it's recording on the computer and I'm not always near the computer and I have a mask on. But we'll just see how it works, and I think this will be better than nothing, to have at least a recording of what I went through on the board. Okay, so we're going to start today. This week in class, we're going to do section 1.7, and then on your own, you should go over section 2.1. I don't have the video up for this yet, but I should have it up by tomorrow. So this section is called linear inequalities in one variable. So let's talk about what an inequality is. So an inequality means not equal. So you'll see 4 different types of problems in this section. You'll see less than problems, greater than problems, and then less than or equal to, and then greater than or equal to. So we'll see all 4 of those different types of problems in this section. It seems kind of random on the homework, like which ones you get. Like for example, say you have a problem and on the practice and it's a less than problem. If you do like try a similar question, it might come up to be a greater than problem. So it seems random. Like you may end up getting all less than problems. You may get all greater than problems, or you may have a mix of everything. All right, so we're going to do 2 different types of linear inequalities. Then we'll do absolute value inequalities. And then we have a word problem at the very end. So I tried today to really pare it down to just a few examples. That way we can try to get through everything. The last couple of classes I haven't been able to get through everything, so I tried to just get down to like the bare minimum so we can get through everything today. Here, I'll make that bigger so you can see it better. All right, so important to pay attention to the directions here. It says solve the linear inequality. Use interval notation to describe the solution set. All right, so interval notation refers to parentheses and brackets. All right, so interval notation refers to parentheses and brackets. So we're going to solve the linear inequality, basically get x by itself. We're going to use interval notation to describe our answer. And then we'll graph the solution set, which will just be on a little number line. All right, so when it says graph the solution set, it's always on a number line. All right, so there's our first problem. I picked this problem because there's an important quality of linear inequalities that's going to come up in this problem. An important property of linear inequalities. So this one says 5 minus 2 times x minus 3 is less than or equal to negative, and then in parentheses 1 minus x. The first thing you got to do is just simplify both sides separately. So just kind of ignore this right-hand side for a minute, work on simplifying this. Then we'll go over, we'll simplify the right-hand side, and then we'll work on getting all of our x's on one side. When I'm doing inequalities, I like to always put the x's on the left, but that's my preference. You don't have to put the x's on the left. It just makes it, to where you're always reading them the same every time. All right, so let's start right here. We're going to multiply through by -2. That 5 is just going to stay out front. So 5. -2 times x is -2x. -2 times -3 is +6. less than or equal to. And then we'll go ahead and distribute the negative on the right hand side. So we're just multiplying through. You can pretend like there's a little 1 right there. So multiplying through by -1. So that would be -1 times 1 is -1. -1 times -x is plus x. So now I'm going to combine like terms on the left-hand side. What are my like terms? 5 and 6, yeah, so that's going to be 11 minus 2x less than or equal to -1 plus x. That side stayed the same. Now we've got everything simplified. Now we can work on moving the x's to the left, move all the numbers to the right. All right, so subtract x from both sides. It's going to cancel out right there. Now you probably can do some of this like in like combined steps. I'm just doing it all separately. So now I'm going to move that 11 over. How should I move that over? Subtract it. Yes, it's right now it's positive. To move it over, we need to subtract it. Try that again. So it cancels out over here. We have -3x less than or equal to. Notice I'm just being really careful to rewrite my inequality every time. It's easy to like accidentally replace that with an equal sign in the middle of it, in the middle of the problem. So just make sure you're being really careful rewriting that correctly every time. -12. Okay. Last step is to do what? Yes, divide by -3. Now, this is the important property that I wanted to show you about inequalities. When you divide by a negative, so let's write this over here somewhere. When you multiply or divide by a negative number, y'all remember what happens to the inequality? Yes, it flips. So when you multiply or divide by a negative number, you must flip the inequality. Sorry, there's all these little dots on the screen. It's like every time my finger gets close to the board, it thinks I'm wrong. So when you multiply or divide by a negative number, you must flip the inequality. If you divide by a positive number or if you multiply by a positive number, you don't need to flip anything. Only when you multiply or divide by a negative number. So only when you multiply or divide by a negative number. Let me extend this page a little bit, if I can. There we go. This is very, very important. All right, so we're going to flip this inequality. Over here on the left, we have x. This inequality flips. Now it's pointing the other direction. The little equal to under there doesn't go away. All right, now what is -12 divided by -3? 4. All right, so first step is done. We've solved the linear inequality. Now we need to describe the set in interval notation, and then we need to graph the solution set. I like to do that in the opposite order, so I like to graph it first and then do the interval notation. I think that the little number line helps you write the answer in interval notation. So draw yourself a little number line. Mark your relevant number here, it's 4. All right, so one thing to remember, another thing to remember, is if you have less than or equal to, let's just write the symbol. If you have less than or equal to or greater than or equal to, those are going to be represented by a bracket. if you have just a less than or a greater than, that's going to be represented by parentheses on the number line. All right, so less than or equal to or greater than or equal to is represented by a bracket. Just less than or greater than is represented by a parentheses. Okay, so let's look at our answer here. It says all of the x's that are greater than or equal to 4. All right, so which side is the numbers that are greater than 4, the left side or the right side? Yeah, so the ones that are greater than 4 would be to the right. So like think over here, this would be negative numbers, like negative 10, negative 9, that kind of thing. Over here is going to be positive numbers. Numbers that are greater than 4. All right, so now we shaded, now we just got to decide, do I put a parentheses or a bracket? So which one do I put here since I have an equal to? A bracket. And you want to just open the bracket towards the side that you shaded. So it'd be like this. And now your number line, your graph is done. Now we can go ahead and describe this number line using interval notation, parentheses and brackets. All right, so we already know it starts off, everything, no, there's nothing shaded here. It starts off right here at 4. And it's shaded all the way till what's the biggest number out here? Infinity, yeah. So this is positive infinity out here. What's over here? Negative infinity. All right, so it's 4 to infinity. Now we got to decide parentheses or brackets. We already decided right here that a bracket should go around 4. You always, always, always put parentheses around infinity. All right, so there's our 2 answers. Here's the first part right here. Or excuse me, this is actually the first part. And this is the second part. Let me write that over here. So you always put parentheses around positive infinity and negative infinity. All right, so let's do another example. Again, I picked this example because we had to divide by the negative, so that way you could see that property. We're going to look at compound inequalities now. Compound inequalities are just where you have 2 inequalities put together. So in the book, they also refer to them as like double inequalities. They also call them double inequalities. So you can imagine that you had like 2 different inequalities and you kind of smash them together into one problem. Directions look really similar. They say solve the compound inequality, use interval notation to describe the solution set, and then graph the solution. So this would be a type of problem that would be very important to show all of your work on that written work for the exam. So you just want to make sure that you show all of your work on your scratch paper. You're going to turn in after the exam. And I was thinking if y'all want to, I can set up like a little practice thing where you go in and like practice submitting stuff to the Dropbox. I can set that up, and that way you can have a practice run before the test. All right, so when I look at this inequality, the first thing that I notice is that all these fractions, right? These fractions look like they're gonna make this problem super hard, we can easily get rid of them, and I'll show you how. Now, traditionally, how you would approach this problem is that you would just get rid of the denominator in the middle. So we can do that, or we can get rid of all of the fractions. I'll show you the first way, just getting rid of the fraction in the middle, and then working our way out. And then if you want to, I can show you the alternative method and just getting rid of the fractions altogether. All right, so let's get started. Starting in the middle here, your goal, remember we're trying to solve this, we're trying to get the variable by itself. So here our variable is y, so we're trying to get y by itself. The first barrier to getting y by itself is this 3 down here. We're multiplying by, or excuse me, I said the answer. We're dividing by 3, so what should we do to get rid of it? Multiply by 3, yeah. Accidentally. Now you're going to multiply each side by 3. So multiply the middle, multiply the right-hand side, and multiply the left-hand side. Multiply everything by 3. This is something where you might want to have your calculator out. You can do this in your head. It would just take you more time. All right, in the middle, the 3's cancel. 3 in the top cancels with 3 in the bottom. All right, so if you have your calculator and you want to go ahead and multiply the left-hand side, do that now. You just would write 3 times 10 divided by 6. No parentheses needed anywhere. I think that's going to be, I'm trying to get better at doing math in my head, so let me see if I can guess answers. 4.5, 4.5. Okay, well, no. All right, so 5 on the left-hand side. That worked out pretty nice. You know, it got rid of our fraction. All right, in the middle, remember we just keep that inequality. In the middle, we have y plus 2. And then we have another less than. Now go ahead and multiply that fraction on the right. 23 over 6 times 3. Oh, and it says, I remember on the homework I was looking at this morning, it says use decimals in your answer. So this looks, you know, not so bad. Definitely looks better than what we started with. We're almost done now. Remember, our goal is to just get y by itself. So what should we do to get y by itself here? Minus 2. And again, you're going to do that to every side. So do it to the middle, do it to the right, do it to the left. That's probably the most common mistake here is that people will say, like, just subtract 2 from the right-hand side and they forget to do that over here. All right, so on the left, we have 5 minus 2 is 3, less than 5, less than 11.5 minus 2, 9.5. And we have completed the first step. We've solved it. Now we can go ahead and draw our number line, get the graph, and then we will write interval notation. So draw your little number line. Write your relevant numbers here. It's 3 and 9.5. Make sure you write them in the correct order. 3 is the smaller number, so it goes on the left. 9.5 is bigger, so it goes on the right. All right, so there's actually 2 types of compound inequalities. We'll see the second one in just a little bit. But this type of compound inequality where you have, where they're like combined into one sort of mega inequality, this is called a conjunction. Conjunction. All right, so you can think like, remember that Schoolhouse Rock song, did y'all ever listen to that? right, so like conjunctions are like words that hook up phrases and clauses. Here, conjunctions are inequalities that hook up to inequalities, or it's a type of compound inequality that hooks up to inequalities. So I've said all that to say this. If you have a conjunction, you're always going to shade in the middle. So you always shade. Always shade in the middle. So if you have a conjunction, you always shade in the middle. So we already know the middle part is what's going to be shaded. So in between the two numbers. Should we use parentheses or brackets here? Parentheses, yeah, because there's no equal to. So just open up the parentheses towards the shaded part. That's it. So there's our graph. Our graph is done. Now we just need to go over here and write interval notation. Write your relevant numbers, 3 and 9.5, separated with a comma. That's the shaded part, 3 to 9.5. And then you just put parentheses or brackets around the end. We already know it should be what? Parentheses. And you're done. So the book, I think, will tell you, they'll do the interval notation first, and then they'll make the graph. But I like doing the graph first. I think it helps you write the interval notation. You can do it either way. Just know that if you look at the homework or whatever, they're going to do the interval notation first. All right. Now, the next thing I need to talk about is probably the most complicated topic of the day. This is solving absolute value inequalities. This is the rule. So make sure you write this down. So let me explain this formula really quick. The formula is separated into two different types. You have less than problems and greater than problems. Now, these rules are exactly the same if you have a little equal to under them. You just put the equal to on all the inequalities. Okay? So similar rules apply if you have the equal to. So this would be less than problems and greater than problems. And what this rule or what this formula is saying is that if you have a problem that looks like this, you're going to transform it into a conjunction. If you have a problem that looks like this, where you have absolute value of an expression is greater than A, you're going to transform it into what's called a disjunction. So again, these are called conjunctions. And these are called disjunctions. These are two different types of compound inequalities. The stuff on the right-hand side, this is a compound inequality, this is a compound inequality. They're very easy to differentiate. Conjunctions are always just put together into one big problem. Disjunctions are always separated with the word or. This is something that you definitely want to write on your index card. So remember, you can use a 3" by 5" index card for the test. I'll bring some in on Monday next week. So this would be something good for your index card. Now you're welcome to buy your own index card, but just in case if you don't want to go out and buy a whole pack, I'll bring some in and you can hold mine. All right, so we already know with conjunctions, you shade in the what? Middle. All right, so here you shade in the middle. Disjunctions are going to start up, whenever you start setting them up, they're going to look the same. They're going to have two different numbers. This time you're going to shade on the outside. Right, so disjunctions, you shade on the outside. So conjunctions, you shade in the middle. Disjunctions, you shade on the outside. Let me write this formula down. Can everybody see it if I write it over here? Yeah. So if you have the absolute value of an expression is less than A, then you convert it to a conjunction. If you have a greater than problem, you convert it to a disjunction. Now, I think it's important to point out that also what's inside the absolute values here is normally going to be more complicated than just x. Like you could have something like absolute value of 2x minus 5 is less than 3. So normally you'll have something more complicated than just x here, but the same principle applies. What's inside the absolute value is 2x minus 5, so that goes in the middle. That's supposed to say 5, but it looks like a 6. The number here goes on the outside, so that will be -3 and +3. So it's just like you're taking a problem, an absolute value inequality, you're converting it over into a compound inequality. That was just an example of something that you might see. Let's go ahead and work through that example. I'm going to insert a blank page here. So what did we say? 2x minus 5 is less than 3. All right, so we already saw that we're using that first rule up there for less than problems. We're going to transform it into a conjunction. This number goes on the outside, the positive and negative versions of that number. Whatever's inside the absolute value goes in the middle. Now we're done with the absolute values. We never have to revisit anything with this absolute value. We just solve this like we normally would. So what would you normally do here trying to get x by itself? Add 5. Add 5 everywhere. Cancel out in the middle. What are you left with on the left? 2 less than 2x less than what? I can't believe I made up a good problem here. Usually my problems are awful. Now what should we do? Divide by 2, perfect. Now, what would we have to do if that was a -2 in the middle and we had to divide by -2? Yep, all those inequalities would have to flip. So just keep that in mind. Maybe we'll see another example where we have to flip it. All right, so what are you left with on the left? 1 less than x less than 4. So the solving part is done. Now we just got to make our number line and then write interval notation. All right, so number line, write your 2 relevant numbers, 1 and 4. Make sure you write them in the correct order. Where should we shade? In the middle. Conjunctions, you always shade in the middle. And should we use parentheses or brackets here? Parentheses. Perfect. And now we just write interval notation with parentheses and brackets. Write the numbers in order, 1, 4. That's the shaded area. And we use parentheses on the outside. And we're done. Conjunctions are the easier of the compound inequalities to solve. We'll solve a disjunction in a minute so you can see how those look different. I would say the most difficult part about disjunctions is the very last step where you go to write the interval notation. Everything else is pretty simple. But with disjunctions, the very last step is kind of complicated. All right, so we have another less than problem. This is number 3. Very similar directions. Solve the absolute value inequality. Use interval notation to describe the solution set, and then graph the solution set. Let's make this one a less than or equal to. So we have a 5 on the outside of the absolute value. This is the absolute value here. So 5 on the outside, W plus 5 on the inside of the absolute value, less than or equal to 10. So the way that absolute value inequalities work is that you have to have the absolute value by itself before you start using the formula. So how could we get the absolute value by itself? How do we get rid of that 5? Divide by. Now, why are we dividing by? That's the correct answer. But how do we know to divide? On the outside. Because it's on the outside and it's being multiplied. Yeah. So it's on the outside, it's being multiplied. So we're going to do the opposite. We're going to divide by 5. Right, so that cancels. Absolute value is now by itself. We have absolute value of W plus 5 less than or equal to 2. Now we can go ahead and apply our formula. This is a less than problem, so you're going to use this top formula. The only thing that's going to change is that you're going to write little equal to's everywhere. That's a little equal to's on every one of the inequalities. So what number goes on the outside of the compound inequality? -2 and 2. What's my inequality symbols? Less than or equal to, the same thing here. What goes in the middle? Very good. This one's pretty easy. What do we have to do from here? Yeah, subtract 5. Subtract 5 from everywhere. Cancels in the middle. What's on the left? -7 less than or equal to W less than or equal to -3. W doesn't have any coefficient, so we're done. We're done solving. Now go ahead and draw your number line. Write your relevant numbers. Which one is smaller, -7 or -3? Yeah, -7. So that needs to go on the left. -3 goes on the right. Conjunctions, you shade in the middle. Just shade in the middle. Again, we can tell this is a conjunction because it's a linear inequality that's just sort of smashed together. Two linear inequalities smashed together. So we use parentheses the brackets. Good. So just open the brackets toward your shaded area. Now y'all tell me, what should my integral notation look like? What should it start with? Bracket. -7, comma, -3. Bracket again. Very good. Very good. You think you can do this problem on your own? Yeah. Oh yeah, I can. Let me go back and do that one. I'll write it over here on the board. Thank you for reminding me. All right, so hopefully y'all can all see this. 10 over 6 less than y plus 2 over 3 less than 23 over 6. So if you have another fraction problem similar to this, you can either do it the way we just did in class, which was like get rid of the denominator in the middle by multiplying each side by that denominator. The alternative way that you could do this is to find the LCD of all of those little fractions. So if you look at these denominators, 6, 3, and 6. Can you tell me what the least common denominator would be? 6, yeah. So you can multiply 3 times 2 to get 6. These are already 6, so that means that the LCD will be 6. Then you can just multiply everything by the LCD, and that would get rid of all of your fractions. So here, 6 and 6 would cancel. You'd be just left with 10 here. How many times does 3 go into 6? 2. So that means you'd have y plus 2 times 2. Notice I put the y plus 2 in parentheses because I know I got to multiply everything times 2. And then over here, 6 and 6 would cancel. You have 23. We did something kind of similar. No, yeah, that you must have been ahead. Yeah. Yeah, if you saw a video of this stuff, then that you're already ahead. So does that make sense? That this is the alternative way. I don't necessarily know if it's any easier, but this is just another way you could solve it if you have a fraction. Okay. I have, I think, 2 more problems. Yeah. We have just enough time to do both of these. This is another compound, excuse me, this is another absolute value inequality. It kind of bothers me that they don't make the lines longer here. You want to make sure your lines are really long so you don't mistake this and think that it says like 12y minus 21. So make sure that you really exaggerate those absolute value lines so that you can tell that they are absolute values and not ones. This is the most complicated problem out of this homework. I took this straight off of the homework. All right, so looking at this problem, I can tell that I'm going to have to use the second rule down here because it's a greater than, and I'm going to have to put the equal to's under there because my problem has an equal to. All right, so this, let me just explain the rules since this is the first one we've done. This one says take whatever's in your absolute value, that's going to go on the left. Whatever is going to on the right, you have the negative version and the positive version. Okay, so we're just going to be really careful as we rewrite this. You can write the rule up under here if it helps you. So in our problem, x is getting replaced by this whole thing, 2y minus 2. And then a is getting replaced by 5 plus 8. So let's just write them right underneath that. We have x was replaced with 2y minus 2, less than or equal to negative a, so negative, put little parentheses around the y plus 8. So we'll remember to distribute the negative. The parentheses are supposed to be like a Q to help you remember to distribute the negative. Or x in our problem was 2y minus 2. It looks like a little grumpy face. Is greater than or equal to positive version, which is just y plus 8.
Do you have to play both sides, or you're just showing us how?
No, you have to do both sides. Yes, you have to do both of these. And then I always like to just draw a little line, like right here, and then I just solve them separately. So you just treat them like they're two separate problems at this point. But yes, you always do both. All right, so if you think back to the very beginning of class, this problem here kind of looks like that first problem we did at the very beginning of class. So we're just going to multiply through on the right-hand side, distribute that negative. Remember at the beginning of class, I told you can pretend like there's a little 1 there. Distribute that negative. Left-hand side is going to stay the same. So 2y minus 2 less than or equal to. Negative 1 times y is negative y. Negative 1 times positive 8 is negative 8. Again, we're just ignoring that stuff over there on the right for right now. All right, go ahead and get all of your variables on the left, all your numbers on the right. So I'm going to add y, So over here I have 3y minus 2 less than or equal to negative 8. Now what should I do? Add 2 to both sides. And I think again, this one said write your answer as a decimal if you have to. We're not going to have to do that, are we? What's negative 8 plus 2? Negative 6. I was thinking negative 10. All right, now what? Divide by 3. Again, I'm showing every step. You may not need to show every step. That's fine. I'm not, expecting your work to look exactly like this. You write down whatever you need to write down. You do whatever you can in your head. All right, so that's the first part of our solution set. Now we got to go over there and get the second part. This one's going to be easier to solve. We don't have to deal with that negative. So we could go ahead and move variables to the left, numbers to the right. All right, so minus y, minus y. Now let's try to do this all in one step. What should I do with the negative 2? Add it to the right, add it to both sides, really. All right, so that cancels over here. So what's 2y minus y? Y greater than or equal to 8 plus 2 is 10. And that's it. There's no coefficient on y. We don't need to divide anything. So first part's done. We have our answer. Now we got to do those last two parts. We got to draw our number line. And then we have to do interval notation. All right, so write your two relevant numbers, negative 2 and 10. Make sure you write it in the correct order. Negative 2 is smaller, so it goes on the left. Now, remember with disjunctions, this is a disjunction. Again, they're really easy to spot because they have this or in the middle. So this is a disjunction. With disjunctions, you shade on the outside. All right, so we're going to shade on the outside. Y is less than negative 2, that would be over here. Y is greater than or equal to negative 10, that would be over here. All right, now you're just going to put in your parentheses or brackets. Which one should it be here? Brackets, because we have the little equal to symbol. And you're just going to open the brackets towards the shaded part. So open the bracket towards the shaded part. Our graph is done. Now remember I told you that the hardest part about disjunctions is writing interval notation. they just get really long. So let me show you what this looks like. You're just gonna start on your number line on the very left-hand side. So you start just like how you would read sentences over here on the left. So over here on the left, what would this be? Negative infinity. So out here, this is negative infinity. All right, that's the shaded part over here on the left. So negative infinity all the way to -2. Go ahead and put your parentheses and brackets around this. What goes around negative infinity? Parentheses. What goes around -2? Bracket. Now we have this gap in the middle. The gap is always going to be represented by this symbol. It's called a union. Just looks like a U. So anywhere that you have a little gap, it gets represented by that big U. This is just a symbol that lets us connect parentheses and brackets or connect two intervals. Then we pick back up here at 10. Does 10 have a parenthesis or a bracket around it? Bracket and comma, and shaded all the way to where? And that's it. All right, so I'm going to do the last example, and then I'll come back and I'll just draw a bunch of number lines. So the end class will draw number lines and then practice converting it over into interval notation. Okay, so let's look at this last one. This is straight off the homework, so I'm guessing that you will have this exact same problem and that your numbers here will be different. All right, so if you want to take a picture of it, it's kind of long, but it says, in a class where the final course grade depends entirely on the average of 4 equally weighted 100-point tests, David has scored an 85, a 76, and a 92 on the first 3. So he's in this class. Your entire grade depends on your test average. He has 4 tests. He's already taken 3 of them. He's made an 85, a 76, and a 92. What range of scores on the 4th test will give David a B for the semester? So which means between an 80 and an 89. All right, so we know that David needs his average to be between an 80 and an 89. You have 2 numbers on the end. That looks like a conjunction, right? So we're going to make this into a conjunction. We know that David, the least he can score to make a B is an 80, so we do a less than or equal to. The highest he can score to make it a B is an 89, so we do a less than or equal to again. And then in the middle, you're going to calculate his average. So to do an average, you add up all the scores, divide by the number of tests. So we have 85 plus 76 plus, that's not a negative, that's the dot, an accidental dot, plus 92 plus, we don't know about the 4th test, we'll call it X. And then what goes in the denominator here? 4, because there's 4 tests total. So this is like the average formula. Okay, so 85 plus 76 plus 92 plus X. X is the score on the 4th test. And that's all between 80 and 89. This is just a compound inequality. We can get rid of the 4 in the middle. How can we do that? Multiply everything by 4. Four cancels in the middle. What's 80 times 4 is 320. Less than or equal to, go ahead and write what's left. 85 plus 76 plus 92. We go ahead and add those together if you wanted to. What's 89 times 4? 3 what? 356. Okay. Our goal again is to get X by itself. So Go ahead and add up these three numbers. What do those add to? 252. So 252. 253. Okay. So those added to 253. If you wanted to make it look neater, you could have written that on a separate line. It would just be amazing. Now we need to get x by itself, so what's our very last step that we need to do? Good, subtract 253 from every side. So subtract 253 everywhere. Cancels in the middle. So what's 320 minus 253? 67. That's the lowest he can score to make a B. Less than or equal to x, less than or equal to, what is it? 1 3. So David cannot get an A in the class, but he has a pretty good range for what he can score on the last test to make a B. I can't remember if they asked you to write this in interval notation or not, but if they did, we know that we would do like both of the numbers, 67, 103. What would go around the ends? Brackets, yeah. So we are out of time. I can put up some videos if you would like to see some extra practice on disjunctions. Maybe I'll just do a couple of disjunctions and put that video up just so you can see some more examples. So other than that, on your own this week, you're just doing section 2.1. That video should be up tomorrow. And I hope you guys have a great week. Good day. Bye. I think it opens on February the 19th. Yeah. So we have a little bit of time.
So all the homework is due like before 18?
Yeah, so it's due like the night before the test opens.
This class, this class.
Oh, okay.
I knew all my classes here, but it's not like a repetition.
Yeah.
Like all me and my algebra.
Yeah. Yeah. Yeah, so you'll probably be like bored. But it's better to be bored than, confused.
Yes.
You're welcome.